Hello, everybody. We got some real interesting stuff to do here. Probably not really all that interesting. What we're doing today is absolute value, O-L-U-T, and inequalities, I-N-A-L-I-T-I-S. Now, absolute value is distance from 0 on the number line. 1, 2, 3, 4, 5, 1, 2, 3, 4, -5. So how far is -5 from 0 on the number line? It is 5 units. And this is distance. Now, being that it's distance, it's always positive. I know always is a long time, but S-I-T. Always a positive number. Okay? And we write absolute value with 2 vertical lines. So the absolute value of 5 is obviously 5. The absolute value of -5 is also 5. Remember, because it's distance. It's always positive. Now, if you're so smart, get this. The absolute value of x is 3. What could x be? X could be 3, right? The absolute value of 3 is 3. And the absolute value of -3 is 3. So in this case, x can be plus or minus 3. If you get this, and I'm going to do this to you on a test or a quiz or something, the absolute value of x squared plus 3x minus 2 equals -5. This is undefined because absolute value is always positive. Can't be a negative number. Or it could be just as simple as the absolute value of x equals -5. Could be that too, but still undefined because absolute value is always positive. Okay. Now this can also be written like that, null set. Now we do 2 things here. So if you have the absolute value of 3x plus 2 equals 4, we have 2 possibilities here, the positive and the negative. We have 3x plus 2 equals 4, and 3x plus 2 equals -4. Now, I just got through saying that the absolute value can't be a negative number, right? Well, this is not absolute value. This is just the equation, 3x plus 2. Once we take it out of the absolute value symbols, then it can be negative. Subtract 2, subtract 2. 3x equals, was it 2? Divide by 3. So x is 2/3. And again, subtract 2, subtract 2. 3x equals -6. Divide by 3. X is -2. Okay. And on the number line, it would look like this: 0, 1, 2, 3, 4, 5, 2, 3, 4, -5. X is 2/3, which is a little bit more than half. We'll say right there. And x is -2, which is there. And that's how we would graph that. And for inequalities, say the absolute value of x is less than 5, we can have, excuse me, we can have x is less than 5, or, because if this is negative, we can have x is greater than 5. Okay, less than, greater than. Well, this is good stuff, huh? Okay. Now, what if we have this? If we have 2x plus 1, absolute value of 2x plus 1 is greater than 5. Therefore, remember the three dots in a triangle mean therefore 2x plus 1 is greater than 5, or 2x plus 1 is less than negative 5. The positive and the negative. Wait, did I do that other problem wrong? Okay, subtract 1 from each side. 2x is greater than 4. Divide by 2. X is greater than 2. This one, subtract 1 from each side. 2x less than negative 6. Divide by 2. X is less than negative 3. Okay, so on the number line, excuse me, seems like on the right side I can get my intervals pretty close, or pretty close to even on the left. 3, 4, negative 5. So x is greater than 2. Here's 2, greater than, remember we use a parenthesis. And this is infinity. This one is negative infinity. And x is also less than negative 3. 1, 2, 3, negative 3. Now, how do we write the interval notation? Remember, interval notation looks just like this, except it's written in numbers. We have negative infinity on this side with a parenthesis, and negative 3 on this side with a parenthesis. Or, now remember, or is written like that, the union of, in other words, all these numbers, or 2 comma infinity. Right? Right. Okay, now we can also check for extraneous solutions. Extraneous means EX. Extraneous means not valid or not good or bad, whatever. Extraneous just means that it's not in our set. So let's take a number. Let's take 0. Now 0 is not in our in either one of our areas here. Neither that one nor that one. So it should come out to be incorrect. Put 0 in here. That's 0 plus 1 is 1. Is 1 greater than 5? No. So 0 is false. And you can also plug in numbers that are in there and see if they work. Let's see. Everybody get the idea there? Yeah. Uh, 2x plus 1 absolute value to x plus 1 is less than 7. So we have two possibilities here. We have 2x plus 1 is less than 7, and we have 2x plus 1 is greater than negative 7. Okay, because what we did here was we changed this sign to negative. So whenever we kind of multiplied that by negative 1, so we have to change the sign. So we subtract 1 from each side. 2x less than 6, divide by 2. X is less than, come on, stupid, think, 3. Same thing here, subtract 7 from each side. 2x is greater than, not 7, bonehead, 1. Subtract 1 from each side, I'm sorry, I'll do better. Negative 8. Divide by 2, so x is also greater than negative 4. And how do we graph that? 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, negative 5. Okay, x is less than 3. 1, 2, 3, so it's less than 3. And greater than, x is greater than negative 4. So it's only these numbers in here. Again, we have 3 areas. This area, this area, this area. And let's take 0 again because it's easy. 2 times 0 is 0, plus 1 is 1. Is 1 the absolute value of 1 less than 7? Yes. So we know that this is true or good. Okay, that is absolute value. Wasn't that fun? Now, now we have polynomials, or let's use quadratics. Quadratics. Quadratics and rational, ratio. Inequalities. Yes. You remember quadratics are in the form ax squared plus bx plus c equals 0. This is also called standard form. You are going to see this standard form misery. Drink. Oh, that's a good Diet Coke. Get this if you're so smart. Less than 0. Now remember, we always want to set these equal to 0, and this one is. Now we're going to factor this thing. What are the factors of negative 12 that add up to negative 1? You can do that on your own, but I'll tell you it's x minus 4 and x plus 3 less than 0. And you remember how we solved these before when they were equations? We set each one of these equal to 0, but this one we're going to set each one of them less than. So we have x minus 4 less than 0, or x plus 3 less than 0. Now, if you're using the book at all, I think you're going to find the book is very confusing. I'm going to show you a way here I think is really pretty simple. But you can use the book if you want, but don't blame me. Okay, so we're going to add 4 to each side. So x is less than 4. This one we subtract 3 from each side. X is less than negative 3. Okay, so the easiest way of doing this, I think, is graph it. 1, 2, 3, 4, 5. 1, 2, 3, 4. Negative 5. Okay, x is less than 4. That's here. And x is less than negative 3. 1, 2, 3. Now we have 3 areas. Negative infinity, positive infinity. We have this, we have this, and we have this. If you'll take a number, let's take 0 again because it's easy. 0 squared, we have x squared minus x minus 12. If we put zeros in for the x's, 0 minus 0, less than 0. Okay, 0 minus 0, 0 is negative 12, less than 0. Negative 12 is way over here. Is it less than 0? Yes. So we know that this area is correct. Well, let's put 5 in here just to see if this area is correct. So 5 squared minus 5 minus 12. Is that, we put a question mark up there, so is that less than 0? 25 minus 5 minus 12. 20 minus 12. 20, was it 8? Is 8 less than 0? No. So this area is no good. That's an extraneous solution. And the same thing with the negative 5. Now if we put negative 5 in here, we're going to get negative 5 squared minus 5 minus 12. Is that less than 0? 25 plus 5 minus a minus is a plus, minus 12. Is it less than 0? 30 minus 12 is, I think, 18. 18 is not. That one's that way too. Oh, stupid. Sorry. 18 is not less than 0, so we know that this area is not in our. So it's only between these two, here to here. So we have negative 3, comma 4 is our interval notation. Right? Right. I think you're going to find that that's the easiest way. You can put it in your calculator and it'll tell you whether it's true or not true, but it'll tell you if the area is correct. Okay. Let's do another one. Okay. Hope y'all appreciate this. I'm wasting all this paper on y'all. Don't tell Dr. Austin I said anything about wasting paper. X squared plus 3. Oh, before I forget, if y'all need a notebook, a spiral notebook kind of like this, I have a whole bunch of these things there at school. If you need one or you want one or whatever, please tell me, because I'm so stupid. I go to Walmart and see how cheap they are, and I'll buy 10 of them every time I go. Okay, plus 3x minus 28 less than 0. Now I'll tell you the factors of this are x plus 7 and x minus 4, again less than 0. So we set each one of these to less than 0. So we get, excuse me, x plus 7 less than 0, and or, I think it's going to be or, x minus 4 less than 0. We solve each equation, you're going to get x is less than negative 7, right? We subtract 7 from each side. Here we add 4, so x is less than 4, right? Right. Okay, and again, I think you'll find this is the easiest way of doing this. Make a little graph, 1, 2, 3, 4, 5, 1, 2, 3, 4, negative 5, 6, 7. X is less than negative 7, so we're talking about that area. And X is less than, or these are our two areas here to here. So we have this area, and this area. So again, let's take 0 and plug it into x squared plus 3x minus 28. Is that less than 0? 0 plus 0 minus 28, right? This is 0, that's 0. Is negative 28 less than 0? Yes. So we know that this is true. Now let's take 5. 5 squared plus 3 times 5, right? We're going to plug 5 in wherever there's an x. Minus 28. Is that less than 0? 25 plus 15 minus 20. That's 40. Minus 20 is 20. 20 is, stupid boy. 20 is not less than 0. So this one is not in our area. And if you put a number over here like 10, it's going to come out to be false also. Let's see. Whoops. Sorry. I'll do better. Okay. We're going to take our original equation. Take negative 10 squared. Okay, we're going to take this number over here because it's in this area that we're kind of talking about. Negative 10 squared plus 3 times negative 10 minus 28. Is that less than 0? That's 100. Because remember, excuse me, negative 10 squared is a positive 100. 3 times negative 10 is negative 30 minus 28. Is that less than 0? Let's see, 30 and 28 is a negative 52. I'm sorry, 58. So this would be 42, I think. Let's see, it's 70. I think that's right. Is 42 less than 0? No. So this area is not in our, that's not in our area. Okay, so what would be our, what would be our interval notation? Negative 7 on this side with a parenthesis because it does not include it, and 4 on this side. Isn't that fun? You gotta take a whole piece of paper to do that one problem. Aren't you proud of yourself? Okay. Now we have this. It's the last one. Then you can go home for the weekend. Oh, what about a quiz? You think we ought to have a quiz? Mr. Solomon said he thinks we ought to have a quiz. Mm-hmm. Mm-hmm. X squared. Okay. Now, what are the factors of negative 5 that add up to this? It's going to be x minus 5 and x plus 1. Yeah. Greater than 0. So we take each one of these and set them equal to 0. Excuse me. X minus 5 greater than 0, or x plus 1 greater than 0. So x is going to be greater than 5. I'm going to add 5 to each side. And x is greater than negative 1. And negative infinity and positive infinity. Okay, here's 5 right here. And negative 1 is here. So, again, we have 3 areas of interest. Here, not very interesting though, is it? There. Now again, the easiest thing to do, let's take 0. Unless it's one of the answers, you don't want to do that. So let's take 0 and plug it into our original equation. X squared minus 4x minus 5. Is it greater than 0? 0 and 4 times that, 0 minus 5. Is minus 5 greater than 0? No. Okay, so we know that this area right here is not in our area, is not going to be a solution. So now let's put in, see, 5. So let's put in 6. 6 squared minus 4 times 6 minus 5. Is that greater than 0? 36 minus 24 minus 5. Is it greater than 0? Now again, you can plug this into your calculator and it'll spit out the answer. 36 minus 24 is what, 12 minus 5 greater than 0? Yes. Is 7 greater than 0? You betcha. So we know that this area is true. It satisfies the equation. So now let's take negative 5. Negative 5 squared minus 4 times negative 5 minus 5. Is that greater than 0? 25 minus a minus is a plus. Plus 20 minus 5. Is that greater than 0? 45 minus 5 is 40. And we know that 40 is greater than 0. So this area is true also. So now what does our interval notation look like? Well, stupid. First of all, let's use the lower side. What's on the low side? Negative infinity. That's the least this could be. What's on the high side? What is that? Negative 1. And union, because it includes all the numbers here and here. And again, we have 5 comma infinity. Right? Oh, I'm sorry. Stupid boy. Okay? Let me let you soak that one in for a while if you're so smart. Let's see you get that. Okay, that's all I have. Y'all take care. Bye-bye. Bye, bonds.